Hello students, and welcome back to another geometry video. You know what to do. Pause the video, try these problems in your notes, and then unpause it to do it with me. Okay, so there are two parts to this question. First, identify all pairs of congruent corresponding parts, and second, find the value of x. It's important to note that we are told in the diagram these shapes are congruent. This is very important because if these shapes, these quadrilaterals, because they have four sides, if these quadrilaterals were not congruent, their corresponding parts wouldn't be congruent. So, the reason that we can identify pairs of congruent corresponding parts is because the shapes are congruent. And the reason we can find the value of x is because the shapes are congruent. So, we'll do part 1 first, and then we'll do part 2. Identify all pairs of congruent corresponding parts. Now, maybe you can see, just by looking at this diagram, maybe you can see, E is the most pointy. E is the smallest angle. So, G is the smallest angle. G and E must go together. Maybe you can see that just by looking at the diagram. I want a little bit more. I want to redraw quadrilateral CDEF so that it looks exactly like ABHG. I want a shape that looks exactly like it. Okay, so how could I move quadrilateral CDEF? How can I move it so that I get this shape? Well, I just need to turn it, right? I just need to take it and turn it about 90 degrees, maybe a little bit more than 90 degrees. So E would be here, F would be in the bottom left, C would be in the top left, and D would be in the top right. And don't forget, we need to move all of our markings too. So C is a right angle, D is a right angle, F is 105 degrees, and E is 75 degrees. Okay, perfect. Now I can see. Yes, now it is clear to see. A goes with C, B goes with D, etc., etc. Now I see. So, remember that when we identify all pairs of corresponding parts, we're going to have angles and we're going to have sides. So the angles, I have angle A is congruent to angle C. I have angle B is congruent to angle D. Angle G is congruent to angle E. And lastly, angle H is congruent to angle F. Okay. Now remember, we also, I'm in the way. Okay. Remember that we also could have looked at our congruent statement. A comes first, C comes first. So A is congruent to C. B goes second, D goes second. So B is congruent to D. And G is third, E is third, so G is congruent to E, etc., etc. Now, we can do the same thing for our sides. I can say AB, and in fact, let me write it a little lower. AB is congruent to CD, because A and B are the first two letters, and C and D are the first two letters. Now let's check. AB is right here. Does it match up with CD? Yeah, they're both on the top of our shape. So perfect, perfect. Okay, let's keep going. B and G, 2 and 3. D and E are in places 2 and 3, if I'm thinking about A is 1, B is 2, G is 3, H is 4, like that. So that means that BG must be congruent to DE. Let's check. BG, DE. They're both on the right. Perfect. And now GH, EF should be the same. Should be congruent. And GH, F, or EF. Perfect. And that's 3 tick marks. Awesome. And if we wrap around 4 and 1, so we'll take HA, that should be congruent to FC. If we like wrap all the way around, you can think of it like that. And we can check HA, that's 4 tick marks. 1, 2, 3, 4. HA and FC, and HAFC. Perfect. Perfect. So these are all pairs of congruent corresponding parts. I'm going to be over here. You don't need to see the angles anymore. We're done with that part. Okay, next we need to find the value of x. I'm going to get rid of these tick marks. We don't need them anymore. Not necessary. Okay, so I see that I have 4x plus 5. That's angle H. Which angle goes with angle H? Well, angle F goes with angle H. So that means that 105 needs to be the same as 4x plus 5. Now remember, if you wrote 4x plus 5 equals 105, same thing, right? It doesn't matter if I say x equals 2 or 2 equals x, it's the same thing. So now we just need to solve this equation. Subtract 5 from both sides. We get 4x equals 100. Divide by 4 on both sides, and we get x equals 25. Because if I take $1, how many, and there are 4 quarters in $1, quarters are worth 25 cents. That's how I remember 100 divided by 4. Pro tip for ya. Okay, we identified all pairs of congruent corresponding parts, and we found the value of x. So, we are done. And let's go ahead and move on to what we have for today. Now I know that if you're watching the playlist of the YouTube videos, or if you're in my class, we are doing 5.4 before we do 5.3. And I do this on purpose. 5.3 is very similar to 5.5 and 5.6, so I just switched. We're going to do 5.4 first. That might change if you're watching this 10 years in the future. That might change. But for now, we're going to do 5.4 before 5.3. So 5.4 is all about equilateral and isosceles triangles. We talked about these in 5.1. Equilateral. Do you remember what an equilateral triangle is? And isosceles. Do you remember what an isosceles triangle is? Check yourself. We're going to talk about it today, of course, but check and see if you can remember now. And our learning target for today is, you remember what equilateral and isosceles triangles are, and you know what the Base Angles Theorem states. The success criteria is that you can use equilateral and isosceles triangles and the Base Angles Theorem to solve problems. So, equilateral, isosceles triangles, Base Angles Theorem. So, let's jump right into it. Parts of an isosceles triangle. Remember, all isosceles triangles, we can put these tick marks here because isosceles triangles, isosceles triangles mean that at least 2 of the sides are congruent. So this leg and the other leg is congruent. Now please put this picture in your notes, label it isosceles triangle, because this is some important vocab for isosceles triangles. We call the two sides that are congruent, we call legs. They have two legs. We call the other side, the third side, that might not be congruent to the legs, we call it the base. And the angles that share a base as one of the rays for the angle, so the angles that are near the base, we call base angles, because they're right near the base. The other angle, the one in between the two legs, we call the vertex angle. So please make sure that this is in your notes. If you'd like to color code, I always encourage color coding. Vertex angle in between the legs. The legs are the two congruent sides, and the base angles are near the base, which is the side that might not be congruent to the legs. Okay, alright, now that you know the parts of an isosceles triangle, we're going to use these vocab words in our first theorem for today. We have the theorem and we have the converse of that theorem. So, the Base Angles Theorem. This was in our learning target and our success criteria. If two sides of a triangle are congruent, then the angles opposite them are congruent. So if AB is congruent to AC, if two sides of the triangle are congruent, then angle B and angle C are congruent. The angles opposite the sides. So angle B is opposite of the side AC. And the way that I think about that is if you draw an arrow away from the side, this is the only angle that you're looking at. Angle A is right next to this side, and angle C is right next to the side. B is the only angle that's opposite the side. So, if two sides of a triangle are congruent, then the angles opposite them are congruent. So the angle opposite from side AB is angle C. So, why is this called the Base Angles Theorem? Well, look. Here are my legs. My legs are the two sides that are congruent, which makes BC, side BC is my base, which makes these angles base angles. Ah, so if I have an isosceles triangle, the base angles are congruent. And I know that's not exactly what the theorem says, like word for word right here, but it is what the theorem means. So let's write that over here. If a triangle is isosceles, then the base angles are congruent. And we're using some shorthand here. This means angles, this means congruent. Wonderful. Okay, fantastic. Now, the next theorem is the converse of the Base Angles Theorem. Remember that the converse means I switch the if and the then. So first we had if a triangle is isosceles, then the base angles are congruent. What the converse says is if the base angles are congruent, then the triangle is isosceles. So we're switching the if and the then. If a triangle is isosceles, then the base angles are congruent. The converse is if the base angles are congruent, then the triangle is isosceles. So, if angle B is congruent to angle C, then side AB is congruent to side AC. So, if two angles of a triangle are congruent, then the sides opposite them are congruent. So the side opposite from B is AC, and the side opposite from angle C is AB. So, if the base angles are congruent, then the sides are congruent. The opposite sides are congruent. And the triangle is isosceles. Okay, wonderful. So, here is the base angles theorem, the converse of the base angles theorem. This was in our learning target, was that you know what this says. So make sure that you know. Can you put this in your own words? Can you put the base angles and the converse of the base angles theorems in your own words? And the success criteria said that you can use them. So, let's use the base angles theorem. In triangle DEF, triangle DEF, DE and DF are congruent. Okay, so they put these tick marks here for us. That's great. DE is congruent to DF. Name two congruent angles. Hey, okay. If a triangle is isosceles, then the base angles are congruent. So, these are my base angles, right? No. I know that it's easy to think, oh, the bottom is the base. So the base angles are the angles on the bottom. No. Remember, the angles, or the sides that are congruent are my legs. The other side is the base. So these are my base angles. So the two congruent angles are the ones opposite the congruent sides. So the angle opposite side DF is angle E, and the angle opposite DE is F. So, two congruent angles are angle E and angle F. Another way you could write this is just angle E is congruent to angle F. Both of these answers would be acceptable for me. Okay, wonderful. Let's check and make sure that we were correct. DE is congruent to DF, so by the base angles theorem, angle E is congruent to angle F. Perfect. Yay! Okay, let's go ahead and move on to another theorem for today. A corollary to the base angles theorem and a corollary to the converse of the base angles theorem. Remember that corollary means that once you prove the base angles theorem, this theorem follows very easily. It's very similar to the base angles theorem. So, the corollary to the base angles theorem says, if a triangle is equilateral, then it is equiangular. So if the sides of a triangle are the same, then all the angles must also be the same. So, if we wanted to write the first one in our own words, we could say, if all sides of a triangle are congruent, then all angles of the triangle are congruent. And I'm using shorthand again. This means triangle, this means congruent. Okay. And the converse, or the corollary to the converse, remember we switch the if and the then. So if a triangle is equiangular, then it is equilateral. So now, if the angles are congruent, then the sides are congruent. So if all of the angles of a triangle are congruent, then we know all of the sides are congruent. So basically, if you see a diagram where all the angles are the same, boom, you know all the sides are the same. And if you see a diagram where all the sides are the same, boom, you know all the angles are the same. So if sides the same, then angles the same. If angles are the same, then sides are the same. Cool. All right, let's see this example in action. Finding the measures in a triangle. Find the measures of angle P, angle Q, and angle R. Okay, well, let's look at our diagram. All the sides are congruent. Look at that. PR is the same as QR, which is the same as PQ. And if all the sides are the same, then all the angles are the same. So this means that angle P is congruent to angle Q, which is congruent to angle R, which means that the measure of angle P, however many degrees angle P is, that needs to be equal to however many degrees there are in Q, which needs to be equal to the number of degrees in R. So the measure of angle P needs to be the same as the measure of angle Q, which needs to be the same as the measure of angle R. Now, we still need to find the measure. What is angle P? What is angle R? Well, we know that all the angles in a triangle add up to 180. So, we know that the measure of angle P plus the measure of angle Q plus the measure of angle R should equal 180, right? Measure of all three angles needs to add up to 180. We remember that from 5.1. Okay, but Q is the same as P. So we can just say the measure of angle P plus the measure of angle P plus the measure of angle R is also the same as the measure of angle P. So we can replace this with the measure of angle P. And this gives us, so 3, we have 3 measure of angle P's, right? There's 1 here, and 1 here. So if I add them all together, I have 3 of them. This equals 180 degrees. If I divide by 3, I get that the measure of angle P is equal to 180 divided by 3 is 60. And because the measure of angle P is the same as the measure of angle Q, which is the same as the measure of angle R, this means that the measure of angle Q is also 60 degrees. And the measure of angle R is also 60 degrees. All the angles of the triangle are 60 degrees. And this is true for any equilateral triangle. And if this was confusing to you and you're like, wait a minute, I don't know what was happening, we can take it back a step and we can say, okay, P is it's x degrees. It's x degrees. But Q and R are the same, so they're also x degrees. And that means that x plus x plus x is 180 degrees. 3x equals 180 degrees, and if we divide by 3, we get that x equals 60. So all of these are 60 degrees. Now this is true for any equilateral triangle. The angles will be 60 degrees. Because always, the angles of a triangle always have to add up to 180 degrees. And if they're all the same, the only way for the angles to be the same and add up to 180 is if they're 60. And if you don't believe me, try. Try to find, another number that if all of the angles were that number, they'd still add up to 180 degrees. Try it, but you won't be able to. Okay, we can check and make sure that we were correct. 3 times the measure of angle P is equal to 180. Measure of angle P is 60, so the measures of all of them are all 60 degrees. Booyah! Awesome. Okay. Now, one last example. We're going to put them together. We talked about the Base Angles Theorem and the Converse. That was about isosceles triangles. We talked about the Corollary to the Base Angles Theorem. That was all about equilateral triangles. But now I want to put them together. We're going to talk about isosceles and equilateral triangles in this example. So, we are asked to find the values of x and y in this diagram. Okay, let's just take a step back and ingest all of the information we're given here. I have y, I have 4, and I have x plus 1. X plus 1 goes with side LM, 4 goes with KL, and y goes with KN. Okay. Now, let me look at the angles. I notice that in the triangle on the left, right, there's 2 triangles in this diagram. There's KLN and there's MNL. So there's 2 triangles here. If I look at the one on the right, I notice that all of the angles are congruent, which means all of the sides are congruent. Because, remember, all the angles are the same, all the sides are the same. So that means that y has to be the same as 4. So right off the bat, I know y equals 4. Y equals 4. Okay, and let's see. Okay, so now let's look at the triangle on the right, because now I want to know x. So I need to look at this triangle. Now I notice that these 2 angles are congruent, which means that the sides opposite them need to be congruent. So, LN needs to be congruent to LM. So, x plus 1 is equal to whatever this side is. But this side is 4, right? All of these sides are 4. So x plus 1 has to be equal to 4. And subtract 1 from both sides. X equals 3. Awesome! Awesome. Cool. Let's check and make sure that we were correct. Okay. Because triangle KLN is equiangular, it is also equilateral. So y equals 4. Perfect. And because angle LNM and angle LMN are congruent, then these sides are congruent, and triangle LMN is isosceles. So LN is equal to 4, which is equal to LM, which is x plus 1. X equals 3. Woohoo! Yay! Wonderful! Awesome. Okay. That is all I have for you today. Thank you so much for watching the whole video. I mean, keep watching, it's not done yet. Remember, if you have questions, ask them. See how these are made out of speech bubbles? Speech bubbles because you're asking your questions. You're getting them answered. It's great. It's fantastic. And now is a good time to check your understanding of the learning target and the success criteria. Do you remember what isosceles and equilateral triangles are? Do you know what the Base Angles Theorem says? And can you use isosceles and equilateral triangles and the Base Angles Theorem and its corollary to solve problems? rate yourself on a scale of 1 to 3, where 1 is, I need help, and 3 is, I got it, I feel so good. And if you are, if you are a 1, get some help. After school tutoring, talk to your teacher, talk to a friend, and if you're a 3, help your friend that is, that's a 1. So, okay. And practice problems. So, these problems on the screen are like example 1, example 2, and example 3. So, give them a try, but remember to still do the homework that your teacher has assigned as well. But you can do these problems to practice the skills that you have learned in this video. And as always, let's end our lesson with a launch. And today's launch comes from an anonymous and unknown person, but it says, what comes easy won't last long, and what lasts long won't come easy. If you want something, you're like, oh, I just want math to come easy to me, that won't last long. The more you have to work for it, the harder it comes, and the more you have to work for it, the longer it's gonna last. If you spend hours studying, you're gonna remember that math longer than if you just got it first try, boom, boom, shove it in, be done with it. That's not gonna last long. So if you're ever like, I just want it to be easy, what comes easy won't last long. And what lasts long won't come easy. And you want things that last long. You want a relationship. You want love that lasts a long time. You want knowledge and understanding that lasts a long time. So, if it doesn't come easy, that's okay. It probably shouldn't come easy if you want it to last a long time. So, work hard. Don't be sad if it doesn't come easy. Keep working hard and be proud of yourself for working hard, because it's gonna last a long time. That is my launch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day, and thanks for being here. Thanks for watching. Bye.